Hey, switch on your cameras. Welcome to class. Again, this is the last of week 9. Yeah, week 9. So you only have 2 more weeks of class. Um, and it's fun. It's fun. I think whenever we're getting to do more exciting stuff. Anyway, before we get started with today's class, um, I wanted to, Isidore is supposed to be here, or he said he'll be here at some point, I think. He was actually very interested in this RSLS project too. Oh, look, Peter is here. Well, actually, I'm going to give him a cookie so he can see. Well, no, eat it, eat it, eat it. Go to brother. No, go. വെള്ളപ്പോ. He comes at this time. Um, even though he doesn't have a clock, his biological clock is very accurate. Okay, it's kind of cool. Anyway, was I saying? Yeah, okay. So I think this would be a fantastic opportunity for you guys to do a joint project and a paper. And I will guide you through every single step of this process, right? Except I'm not going to be a formal, I'll just do everything informally. And I'm not going to be a co-author or anything like that. So basically, what that means is that I'll tell you what the next step is and what you have to do, but you guys have to go ahead and do it every single step of the way. Yeah. So it's not going to be walked through every single step, but it's going to be fun. And essentially what's going to happen is that Isidore, who also has experience with JavaScript and web apps. So I'm going to ask him to take the code that you guys had before, Grady or something like that. Yeah, someone, Rui, who wrote the thing that I was playing with? Grady. I don't know. One of you had the latest version that I played with. And then it led to a whole series of interesting things, right? So you played with that Grady, and then oh, actually, that itself was an idea that came from our testing of vectors, push back and push front, which gave that parabola, very nice parabola. And that's when I think we had the idea, well, you know, it's a parabola. Let's actually try and make a game out of this. And that's when the Grady game was born. Yeah. So anyway, that code, we'll just ask Isidore or ChatGPT or one of those Copilot things. Hopefully you have, some of you have subscription to GitHub. But I'm pretty sure there is a GitHub subscription you can get from Foothill, being a Foothill student. And that would also, I think, allow you to experiment with GitHub Copilot and things like that. So even if you yourself are not going to be writing the web app to create essentially that game that you have written is going to be turned into a web game that you can play on a URL, either from your phone or from any PC anywhere. Okay, so that's the first step. And I think Isidore, with the help of AI or not, can easily turn this around within a day. And I'll host the game on Nonlinear Media on a server, so you all have that URL. So, and then whoever is part of this project, and by the way, this is only available to those who are ahead in questing, okay? Then I think, and correct me if I'm wrong, if I'm either way, okay? Meaning that I think, Rena, you're kind of ahead on questing, yes?
I do have the last quest left.
No, yeah, last quest, but it's not due until, week 11 or something. Yes, so you are ahead. You're ahead of what was due this week, essentially. Okay, so these are just the people who are eligible to, be part of this project. Okay, Kate, you are ahead too, yes? Yeah, I'm just recalling from
Me?
from the logs.
Oh yeah, I am, but
Yeah?
I'm struggling with number 9.
Yeah. So that means you're ahead. Okay, anyone who's done submitting the quest that is due for this week. I think this week elephant is due, isn't it? Okay, anyone who's already done submitting elephant is a really easy quest. Okay, so if you started, you should be able to finish it in a day, really less than a day. So and so if you're done with the elephant, you can just participate in this extra credit project. It should be done in less than a week. This whole extra credit project will be done within a week. and you'll get extra credit for it, almost as much as an entire quest if you do well the extra credit project, okay? But I will give you lots and lots of, directions with lots and lots of stuff to do too along the way. So everything has to be done, but it'll all be doable within a week. And it will culminate in a presentation at the symposium in May. Okay, so I think the details are there in that link that I sent out. So you can click on it, and you can see there is a symposium that is held, and you'll have to present it. I won't be there, right? I won't be there, but but I'll pretty much at that point, given everything you've done, I'll pretty much have a mental idea of exactly how it's all going to unfold. Okay, and then I'll know how much people will applaud for the hard work done. Okay, so I'll be able to walk you through all of these, and I'm just going to call out people who are eligible to participate as far as I can recall. Sanathan, are you ahead? Are you done with Quest 8?
Yeah, I'm done with Elephant.
Elephant, okay. All right. Anyone who's done with Quest 8, all right, just raise your hand or give me a thumbs up now. And everybody should switch on your cameras right now, okay? Wesley, Chris, Josh, Seth. Okay, well, don't do thumbs up. It's disappearing. Just do your hands, raise your hand so that it stays raised. Yeah, raise your hand. Don't do thumbs up. Okay, so 1, 2, and then Isidore, obviously. So I'm going to get in touch with him. If not, one of you will basically have to take the lead, and I'll tell you how to do it, right? You just have to write a small web app, like less than 100 lines of JavaScript code, which will be very similar to the C code that we wrote. And then I'll host it on the site. And then your job after that is to now use that URL and get as many people as possible to play this game. Now, the way I have had it thought about that was, as you're importing this into JavaScript, you'll also do a little bit of data collection. Basically, you'll ask the user, are you ready to play the Grady game? When they're ready to play, they can either choose visual Grady or some other Grady, okay, analytical Grady, okay? And if they choose analytical Grady, they'll get that, and they'll just get the numerical values. They have to do it in their mind. If they choose visual Grady, they'll, you enter the value, and instead you'll just get a point appear on a Cartesian grid for the given X value. So technically, if you think about it, a parabola is just a conic section, yes? And the maximum number of, the minimum number of points you need to unambiguously detect or tell about a conic section is just 3. Yes, with 3 points, you can get the entire conic section. So I think that visually, most people will be like accurate to getting the thing down to like 3 or 4 guesses by visual. But I think people that do analytically saying, all right, get me the X value, get me the X, unless they're doing it in the head. But you can actually do this. We'll work this out into the JavaScript and the web app so that when they play it, you'll get all the data, how long they took, how many tries they took, and whether it was analytical or so on and so forth. And you can ask other information too on that page, and it'll just transmit it and save it. And at the end of the experiment, and we'll set it up in such a way that you can, anytime, anyone can go to a URL and see how many people have played and what the results are at any time, okay? It's going to be super duper valuable experience, I think, in general, but you have to have the bandwidth to do this because you will learn a new skill of deploying a web app, okay? A web app. And also because C++, interfacing that with C, JavaScript will be easy, and also seeing how these things map together, and also using AI to generate much of the JavaScript and all that code, if it's available now on Copilot. Hopefully, most of you do have the Foothill version of GitHub. Okay, I think it has Copilot for free, so you should certainly try this out. And it will be fun. Okay, so all right, so how many people do we have? Only 4? Nobody else got their hand up? And also we have Isidore. Okay, hey Seth, I thought you were ahead too. No, Rui, you're not ahead?
I am still working on Elephant.
Oh, I see. Okay, Rui.
I think Wesley might be ahead because I remember he posted on Reddit something about elephant. I mean,
Yeah, Wesley. Okay, all right, so 5 and then 6. Okay, 6 people, and I'm thinking that sometime tomorrow we'll just do a very quick 10-minute or 15-minute kickoff meeting, and I'll just describe what needs to get done in the first step involved, which is going to involve Isidore writing the web app or generating the web app in some way, and then all of you guys having a run through it to make sure it all works and everything, so that by the end of tomorrow or by the end of the weekend, really, Oh yeah, the proposal needs to be filled in. That's, it's like a 5-minute job. You just have to visit the URL and fill in some details and say these are the authors, the 6 authors, okay? And I'm not involved at all, okay? I'm just being an informal guide on the site. Just you have to keep that in mind, because don't rope me into anything involved with this presentation or anything, okay? So I'm just doing this for the fun of it, but I think there's a lot of fun that to be had by you guys. So it's very important that you do it without anything else. So I think it'll be great fun. So tomorrow, let me know, or stay behind at the end of today's meeting, and I'll we'll pick a time for tomorrow. And I'll set up a Zoom meeting, and it'll be 15 minutes. I'll say this is what needs to get done. The first step, this is the app we're shooting for. Either generated right now using Copilot in our shared screen, or this is what we want to do the first version and send us a link, and then we'll all play with it. And everybody's happy, we'll just host it on Nonlinear Media, and then you all take it away, and then play it. And then, and as people play it, anybody can play it any number of times. It'll also collect the data, collect it in the background. Any of us can go and click. And at the end, come May, right? So sometime in April, we'll get together, and I'll give you a paper template with the authors and everything set up cleanly, okay? So you can say, this is the raw data, this is what we tried to prove, or tried to investigate, this is what we found. This is our hunch. And that people are more visual calculators or whatever it is, right? And this was found in the data too, or vice versa, or things like that. You'll find interesting things. Yeah, maybe you get even a finer demographic cut. You can say, are you a STEM student or not a STEM student? Okay, so you can actually say, hey, here are some statistics. The STEM students, prefer this approach, 90% or 70%. So all of these interesting, this is, pivot table analysis. This is, basically, this is what a data engineer does. Well, data engineer does much more interesting things. No, I shouldn't have much more interesting things. This is, basically, I think this is more of a job of a product manager. Yeah, looking at the table and lots of information and just cutting and slicing through different dimensions and saying what's and interesting properties will emerge. And it'll be interesting to do this, because even if you're going to be an engineer developing new things, creative products, I think every engineer is also a product manager at heart, because in their mind they already know what they're building, so they're building towards that. Okay, because if you don't have the end in sight, you're not going anywhere. Right, you're just going this way and that way, and you end up, spending your whole life going elsewhere instead of to the direction, right? So if anyone that is building anything, worth anything, already knows in their mind where they're going. So I think, right, or at least they have a very good idea of where they're going. So and sometimes it pans out, sometimes it doesn't. But we hear of great things from the places that panned out. So it's absolutely fantastic. All right, so these five people just stay behind after class today. And then we'll just, for 5 minutes, we'll just arrange for a time tomorrow. And then tomorrow's meeting, I'll make sure Isidore is able to attend to, and then we'll do the first step of this paper. It'll be fun, okay? I think I attended one time, 3 years ago, one of my students, Matthew Waters, his name was Matthew Waters, right? He wrote an app that would, 3 years ago, was it 2019? 4 years ago, Matthew Waters, he's now doing a undergrad or grad work at one of these universities. He created a program called RG, and for extra credit in CS2C and JavaScript, and this was where you go to a website and basically type in what you want in English text, a cartoon, right? An XKCD type cartoon, and it'll draw it for you. When you think about it, this is what our image generation is doing now, except it's doing a much more sophisticated job, essentially, isn't it? But this rg.us that he created, and it was running for a long time, and I was, as informal advisor too. And it was an app that you could basically go and type out your XKCD style cartoon, and it would generate it for you. Because XKCD is just circles and lines and things like that. So it's easy rather than, puppies and playing in snow. So, and it's, it was entirely rule-based as opposed to, statistical or neural net based, which today's AI does. It was a completely rule-based, and it did a pretty decent job. I generated a number of cartoons from it. In fact, one of our specs in CS2C, I think, one of the red quests, I actually have a cartoon that I generated using RG. Now, RG is not there anymore. I think he decommissioned it at some point after he started his grad work, or maybe, I think. But when it was online, I generated one of the comics, and it's in our specs also. It's actually great fun, okay? To play around with JavaScript, know how web apps are created and run. It'll be absolutely fantastic. You know, I'll be very happy to even talk to Matthew sometime and ask him to come by to one of our classes after week 11, right? So week 12, we'll have a free lecture essentially, right? Say, well, you know, we're not doing anything. You can come and ask any question that you want, any informal question, and we'll have, you know, past students come and talk to something like that. Okay, all right. Thank you all so much for raising your hand, and I will, please stay behind after class today, and then we'll talk about that. And so today, here's what I'm thinking. I think first, what we should do is reproduce what we had last class. Hey, Sanathan, you got a question?
No.
All right, okay. Yeah, all right. So we want to reproduce what we did last class, essentially a node, and then in your main, you have a loop that is, well, basically you need a node class and then a print nodes class, or print nodes or print list class, like we did last class. Yeah. Ideally, you should not look at the code that was written last class. So whoever is dictating the code, okay, who, you know, so maybe let's say maybe Seth is on question number 8. Who's on question 9 right now, other than? Actually, you know, it doesn't matter even if Seth is on quest 8, because you're going to be doing quest 9 at some point. Yes, Seth?
Yes, I do plan to do quest 9.
Yeah, so well, you can take the screen if you like, because you haven't coded in a while.
No, I have not.
Yeah, so you can take the screen, and someone else is going to call out the code, and you're going to type in what they type, what they say. And the idea is that you'll just get familiar with all of the stuff that's going in. So by the time you come to quest 9, it'll just be, you know, be a feeling of deja vu rather. Yeah, because you know,
Yeah.
hey, you know what, this is what happens. Okay.
All right. I'm just getting my GDB set up here. How do I?
Yeah, no worries. Yeah, you take your time. Okay, get ready. Josh, are you here? Josh, are you here? Great. Okay, all right. So yeah, so we have a few people who can certainly talk through, because I think Josh talked through the code last class. So today, will try not to talk through unless you're stuck. But someone other than Josh should try to talk through the code. Maybe even more people. Yeah. Rui, you know, Caitlin, Rena. Rena, were you here last class? Well, actually, you had to leave in the middle. Yeah. Are you sick, or you still look sick right now?
No,
too?
my Wi-Fi died on me and my husband was at work. So, and he had like really complicated setup, so I couldn't fix it by myself and I had to wait for him until like 11 o'clock.
I see,
get my
but
internet
you
back.
saw the video later, because we developed that.
No, because like I still don't like I cannot find them. I tried to. I only watched the one that you sent messages about.
Oh, I see. Okay. Well, you know, if necessary, but well, you should feel free to volunteer as well. You know, who's coding right now, by the way? This is Seth. Okay.
Seth.
Yeah, on my screen.
Whenever Seth feels that he wants to hand over, Rena, you should feel free to volunteer too. Yeah.
Okay.
Yeah, it'll be fun. It's pretty much the same. I'm pretty sure Josh can talk this through. Mazen also. Mazen, you were typing last class, yes? Mazen, are you here? Yeah, you guys use thumbs up all the time, and you should all just talk, okay? I didn't. It's just saying yes is faster than looking for, you know, where's that icon I got to press. Yeah. Okay. Hey, Chloe and Faith, are you guys here? Faith, you didn't even respond last time when I asked, are you here? Okay. Can you talk at all? Are you in like a library or something? I don't know. All right. Okay. Hey, Chloe, you're here too, yes?
Yes, I'm here.
Great. So who is I am in the school library right now. I see. Okay. All right. Yeah. And Faith, try to find a place where you can actually talk and have your camera on from next class. You know, even in your library, I'm pretty sure there are conference rooms. Like at Foothill, there's a conference room. Many conference rooms that you can just take and say, well, you know, you can just walk in and say, there's a bunch of students, or just me. I'm going to be in this room for 25 minutes or half an hour, whatever it is. All right. Okay. Thank you so much. Now, someone I hope is going to walk Seth through all of it from the beginning. Okay. So go to the top, and then we're going to add to this because now the time now is 6:21. Okay. So I'm hoping that I give you guys. How about tell me if this is reasonable and doable. Okay. I'm thinking a half hour. That's 6:21 all the way up to 6:50. 6:50. Yeah. So up you get time 6:50, you got to reproduce everything we had. You don't have to have the main with all the loop and everything, okay? That user interaction loop, maybe that can wait. Forget about the user interaction loop. You just need to have a list, and then you need to have the print list function. And then you need to have a way in which you test it. So for the testing, you can do, in your main, you can just add and then, print. So that's all. You got to have all of that done. Is that okay? Can you guys do that? Can I turn around confident enough? Someone can guide Seth through this? Yes?
I guess we will try.
Fantastic, fantastic. Okay. All right. Now, last resort, you can call me, but before you call me, you can also ask Josh because I'm pretty sure he can also talk you through this. Hey, Josh, are you here? You said you thumbs up and all, but I don't know if you can
I'm
talk.
here. I
But
can talk.
yeah, all right, good. You can talk. You're not like Faith. Okay, great. So you can help too. Yes.
Yeah, I can help.
Great. Okay. All right. Great. Excellent. Thank you very much. All right. And if you get stuck, you should call me. Okay. Now it is entirely in your hands. Well, not entirely in your hands. But do it. And I am actually looking forward. I just had this idea that, RSLS, when someone sent me this email today, and I thought, and this Grady was completely coincidental. And I thought, well, that is really cool. I just suggested in a lecture that you guys should do this experiment with psychology students, but why not? We just do it ourselves. I think it is so fun. It is going to be fun to do. I'm actually looking forward to that too. So we'll see how it all goes. I'm going to be here. I'm going to be here. So take it up in half an hour. All right. So and just call me in 30 minutes. Before that too, if you guys need, and I'll help you out. All right. See you later. Have fun hacking. Okay.
Who wants to help me out with this?
I can help you with the only like very beginning from where I actually was present last class.
I
So
don't remember too much of this.
Okay, so we're gonna start with the class node.
Right.
And then I don't think there's anything goes into the parameters. Yeah. So first we're gonna define the private at the same indentation as the class.
No indent before private.
Yeah.
So yeah.
Oh, okay.
Okay, int data. And then that part I didn't really understand because we called the pointer to the object in the definition of the object. So
Yeah, I was
well,
kind of confused about that as well.
okay, so semicolon after data.
Oh, right.
And then class node. No, I'm sorry, just node with the capital N.
Oh, right. Okay.
Yeah, and asterisk
Node,
next. Next.
Oh,
Word next.
next.
I'm
Okay, sorry. I forgot. Yeah. And
Well,
then that was public, right?
Yeah, and then public. Okay, and this is also part that I didn't really understand. Maybe Josh can expand on this, but it's just like one line constructor, I think.
And there's something in the parentheses, right?
Yes, there's int d and then node star p. Then
I think there's a blank. I think I remember.
No. There's a colon.
I thought he had the braces after this. No?
Can someone confirm?
We had a colon and then I believe there was data and then next.
A colon? Like a semicolon or?
No, just that. Yeah.
Just a colon, yeah.
And then, oh, right, that's where you did data.
D.
Yeah, and then.
Next P. Oh, don't forget the comma after data D.
Oh, right. Okay. Data D and
next P,
next
P in,
just like-
in parentheses.
Oh, right, right.
parentheses.
Yeah, I didn't understand this at all.
Yeah, and then there's gonna be empty curly brackets.
Right, right.
So maybe we can ask again how does it work?
Yeah, because honestly,
Yeah.
I don't think I understand what's going on here.
Yeah, same. So I remember the lines, but
I think
the
it's
lines
just
is
taking. I think it's just taking D, putting it in data, taking P, putting it in next.
Oh, so it's like assignment, but in a it's just like a syntaxes thing, or is it some sort of trick? Like it's just a way to write normal constructor in a more compact way, kind of situation.
I guess because this is like a C++ specific feature. Like
Yeah,
I
'cause
haven't seen this in any other languages.
Yeah.
Yeah, me neither.
Okay, so maybe make a comment there. Make a comment to do a little bit of research to explain what it is. No,
Yeah.
after on the same line as the
There's no-
constructor.
All right, you want right
There's
here.
no semicolon in the end. Sorry.
And
There's not. Oh, right. Okay.
and maybe we can talk about it on Reddit too. Share our
Yeah.
findings.
Was there anything else in the class? I don't.
In the public,
we had a bool
there's
function.
a method to set data.
What was a method? Okay.
Oh, well, you
Does-
just go bool set data. Oh, tab first.
Oh, is
but
it in the public?
You are inside of public, yeah.
Oh, okay. I thought. Okay. Set. Data.
Yeah, and you're gonna pass int d. That's it, just in d.
In
I
D.
think.
Okay.
Yeah. And I don't know the logic of the thing. Maybe someone can explain. So if d is less than 0, we're gonna return false.
I think this was basically saying if D is negative, then we set it to the provided value of D, like just to check.
What is d in general? Like, what are we doing with this? What is this? I mean, it's an int, but why it cannot be negative? What is the data in here?
I'm not sure about that either.
Okay, well, we know that it cannot be negative. So, oh, you don't need another curly. You can do it on one line.
Oh, right. Was it just return false?
Yeah, and then if we're not no, I'm sorry, if we're not following that, if we're just saying that data equals d and then return true.
Wait,
In other words, so
is it
data.
so?
Mhm.
If D is less than 0, we're not
Yes, we're
returning
returning
false.
false. We're returning false. All you have is correct.
Okay.
On the next line, data equals d,
Data equals D.
and then return true.
Okay.
And the last one that I have is set next. So void, I don't know why it's void, set next. You pass in there node star p.
I think it's void if it doesn't return anything.
You just assign it. Oh, yeah, that's right. And then you just assign next equals p.
Next equals P. Okay.
Yeah, and someone should take over from here because I will be very lost.
Okay, so then after that, you wanna after the void, after the set next.
Are we still in public?
Yeah. So we're gonna make two getters. So the first one is int get underscore data. And then that's const. So then you want to
Right.
braces are empty. You want the braces, but const after the braces. And
Const after the braces?
After data, yeah. Open and close.
Oh, so const here?
Yeah. And then after data, open closed, just regular braces to
Here.
no, the
Parentheses.
parentheses. Sorry,
Oh, parentheses.
I'm sorry. The language thing. And then inside of the curly brackets, you want to do return data semicolon. And then the next getter is node. And then star get underscore next parentheses. Const. And then inside curly brackets, return next semicolon. Yep.
Okay.
And then you want to have a semicolon on line 30 after the or no, is it? No, sorry.
Yeah, I
Yeah,
don't
I
think we
think
need it.
No, it is, yeah, at the close of the
class.
class, yeah.
Oh, really? Okay.
Yeah. And then after, do we want to start already on like the whole like print node list and all that stuff?
Do we have a choice?
No, I don't know if you wanted to like get into yeah, fine. I was just thinking if we wanted to like work on main first for some reason, but probably not.
Well, if we can test what we have in main, but I don't really see
Yeah.
how.
Yeah,
Like
yeah.
we can make an object and then what?
Yeah, true. All right. Well, so then we have a node class, not class. So
We're still in public?
no,
or-
so this is
I think those are all the methods, right?
yeah, these are methods.
Well, I was saying I think we got all the methods.
Okay, then what's next? Just a function?
Yeah, I guess.
Okay.
So then we want void print underscore node underscore list. And then in that we want to pass a const node star p.
Okay.
And then inside of that, we're going to have a while loop. And then that one, the while statement is p, and then the arrow get next is not null pointer.
Wall P, wait.
P
In the
needs to be in
parentheses?
the parentheses, yeah.
Yes, that's the
Wall
while.
P.
P and then arrow, like a dash, and then yeah, exactly. Get underscore next, and then the parentheses. No, get next parentheses does not
Oh,
equal null pointer.
this is a null pointer in here.
No. So okay, so the parentheses are empty, and then you do the exclamation point and the equal sign for not equals. Null PTR.
Okay.
And then inside of that while statement, we want to have an int data equals p arrow get data.
What is the arrow for?
So it's the same thing as like calling dot in a function. It's just for a pointer.
Mm-hmm.
I don't know if that makes sense.
It does. It kind of does.
Yeah,
Wait,
just
so
like
int
access.
data equals p arrow get data?
Yeah.
Okay.
And then semicolon, and then on the next line, C out, and then left shift data, left shift, and then in double quotation marks, a dash. So yeah, printing a dash, and then semicolon. And then on the next line, P equals P arrow get next, semicolon.
I don't think I understand this function at all.
Well, let's look. Are we done with it? We're not done with it, right?
Not yet, no. And
Okay.
then after the while loop, yeah, right there. You want C out, left shift, P arrow get data, left shift, and then in parentheses. Oh no, not sorry, in the quotation marks. dash null, all capital. I mean, it doesn't matter, I guess. And then another left shift, and then end line semicolon.
Correct me if I'm wrong, but I think this function is just to print it out. That's what we have.
Yeah, exactly. Yeah, so that's so it's basically like a linked list of numbers, and that, yeah, I don't know, shows us the list.
Okay, so it says that while we have something left, when we have next to get,
Yeah.
we assign what we got to data, then we print it out, and then we assign P to the next thing, next pointer. And then we print it out again?
Yes. Yeah, so it's basically just a string, like a long line. Because we have printed like or I guess at the end of the while loop, we then print the next line. But until we get outside of the while loop, it's just one long string of number dash number dash number dash number.
Okay.
And then after this function, there's two more or three more? No, two more. One of them is type node, and then another one type void. So the node one is star, so it's a pointer, add underscore to underscore end. And then in brackets, we want node star p comma and then int data.
Node star p data.
Int data, yeah. And then in curly braces, p arrow set next. P.
Oh, P. Sorry.
Yeah.
I don't know why I heard E.
Yeah.
Set. So you say set next or get next?
Set next. That, or did I? Yes, but that all has to be one phrase. Like there can't be spaces between the P and the arrow on the set.
Oh, okay.
Yeah.
Oh, yeah, that makes sense.
And then inside, into, let me see where I'm not like making a mistake here. Can you scroll down a little?
Down.
Yeah. Okay, so then into that we want to pass new node, and then in parentheses, data comma null PTR.
Is the new node is just us creating a new object of class node? What is the new for? Yeah?
Yeah.
Okay.
New is a keyword in C++. Does set next take two parameters?
Yeah. The null PTR is the next, so it doesn't point to anything yet because it's I think in this function we added to the end. And so then we don't know yet what it points to, so it has to point to the null pointer. And then and then each time that the add to end gets called, then it gets updated, and then something else points to the null pointer.
Okay.
And then on the, you want semicolon, and then on the next line we want to return p arrow get next. Yep. And then we want void add to beginning underscore, yeah, beginning. And then into that one, we want to pass node, like the other one, node star p and int data. And then we want node star temp equals new node.
Oops.
And then that one again is going to take data and null pointer. And then we're going to have on the next line temp arrow set next. And then into that, we're going to pass p arrow get underscore next. semicolon, yeah. Semicolon at the end of that line. And then next line, P arrow set next, and then into that one, we're gonna pass temp. And then that's the end of that. And then after that, we have the int main.
Yeah.
I don't know if somebody else wants to read that out. If you're tired of my voice.
I'm not tired.
All right. So then at the beginning of int main, we want to call srand. Just want to indent that.
Oh yeah.
And then into srand, we want to pass unsigned in
Yeah, in
and
parentheses.
then, time parentheses null pointer. Yep. And then we want to make a new node called start node. So we want node.
Oh,
Yeah, node star start underscore node equals new node. And then into the node, we want to pass -1 and null pointer. And then we want to assign, okay, we have a new star current underscore node.
new start current. Okay.
And then that one equals start underscore node.
Wait, shouldn't we say node star current node and then it's the start node? Oh, line 56.
Oh yeah, yeah. The new is
Yeah.
node.
Yeah.
Oh, node.
Yeah.
Oh,
I
okay.
just I should have phrased that differently. And then after that we have a while loop. So while true. Then we want a char func to do, like FUNC underscore to do. And then semicolon. And then an int input. Semicolon. And then on the next line, a cout with a left shift. And then these were the instructions. I think I have them abbreviated. I think in the original they were a little different. But basically, we want that you want to press a space and then a number to add that number to start, and then
Press
yeah. So I just have it.
press a
I'll
number to
just
start.
show you what I typed. I'll put it in the chat.
Basically, we had two options. One, you could add a number to the beginning of the list, and then one you could add the number to the end of the list. And so for
Oh,
add to
right.
beginning, I think it was
Was it like was it like type A to add a number to the beginning?
and then yeah, and then oh, except A was add number to the end, and then
okay.
I is for beginning. But yeah.
Yeah, Caitlin, do you want to just take over and do the rest of this? My mouth's kind of dry.
So we're after the while. Okay. We still need to be in the while loop.
Okay. Oh,
Yeah.
duh.
1 minute. Yeah, I'm just comparing the different because I had a slightly different formatting. And then okay, and then next we need the CIN. And then oh, I did right shift. Yeah, and then func to do. Semicolon. And then we had switch. Yeah. And then parentheses, function to do. And then open, yeah, that. And then case single quotation A. And then colon, CIN right shift. Oh, you don't need the indent, I believe. Yeah, CIN right shift input. Semicolon, and then current node is equal to add to end, and then parentheses, current node, comma input. Semicolon, and then break. Semicolon after break.
Oh, right.
Yeah, and it's the same thing, somewhat the same thing for I. So same CIN input. And then, oh, except here, it's not current node. We did, I believe, add to beginning. And then parentheses, start node input, start node, comma input.
Oh, okay. Oh, yeah, that makes sense.
Yeah, and then break. And then the last one is default.
Just need a
Colon.
colon.
Yep.
Okay.
And then C out left shift. Something like invalid input. I did invalid input, try again. And then you can period space end line. And then
Just
exit
make these
out of that.
match.
Yeah, I think you exit out of the while loop. And
Yeah.
then print node list. Start node. And then semicolon. And I think, oh wait, we still have return 0. So exit.
I think that's down here.
Yeah, right there. I think that's it. Run it and just to try.
Oh, I have the Zoom panel right in the way. Oh, we got an error. Okay.
Okay, conversion from node to
On line 55.
So is it in main?
Yeah, it's line.
You need a star.
Oh,
before
for start node. Yeah, I see that.
Yeah, you could always add the colon and a space for aesthetic reasons purely.
Oh, yeah.
So you need to type A and then a number, I think, right?
Oh, he did. I think
We did, okay.
he's just typing it on the next line.
Should I do an end line here too? Or oh, something's not right here. Shouldn't this 2 be going to the beginning?
Try again
It's supposed to go after the first one.
after the first
I
one.
think 1 just represented kind of like the beginning of the list. So right now,
Well, it's a -1.
oh, -1, yeah.
Oh, okay. Oh, okay. Cool. Well, I guess that's it, right?
Well, it works. Is there anything else we're supposed to do? Well, most of the
Right.
people have camera
Done?
off.
Is
Yeah,
it
we're
done?
done.
I think that's it.
Fantastic, fantastic. All right, okay. So yeah, let me take a quick look and then we'll go on to the next stage. And I had yeah, let me take a look at the whole code. Can you dismiss the console so we get more code space and then we can take a look at the code. So for me to, right? So we have a node class and then private. Yeah, all right. So we got the constructor.
I think
Everybody
some-
okay with that? That notation is a special thing for shortcut.
I think some of us were, I know I was at least kind of not understanding this line exactly on 15.
So our guess was it's just a construct like a clever way in C to write a constructor.
Yeah, well, I don't know if it's a clever way or not, but it is a shortcut way for sure.
I mean, one line is good.
Yeah, you can also do longer. That curly brace.
Mhm.
Right here.
Yeah, it doesn't. You can just take that to the next line and then have a big function in there.
Hmm.
And besides this thing with data, the initialization of those values with that can happen in other methods too. Doesn't have to happen to doesn't happen to happen doesn't have to happen here. So that notation eventually you'll find yourself using for general functions also. Methods that you write for classes later on in CS2B, you'll find yourself when you inherit, for example, to initialize certain values like that. So it is useful to learn. Right now, it is. I agree that if you've never seen this before, it actually does seem weird. But if you think about it, it is the only thing that is new in all of that is that data D part and then the next P part. Everything else is the same, right? Because for the other one, set default, you got the function just like the constructor. And so the only thing this constructor has extra is those two values in there.
Mhm.
Yeah.
So is this just making D equal to data?
Yeah, that's what that. Yes, exactly. That's what it
And
does.
then next equals P?
Yes.
That's
Initializing
so
the
weird.
values. Initializing the values. Technically, it's not assignment. I think, well, even if it's assignment, compilers will automatically make it initialization because it's nothing, it's, they'll find out, right? It may, they technically, if you look at the compiled code, maybe even most of your variables are missing even, right? So, because the compilers are so intelligent, that they can essentially transform your code into binary, where the logic, well, even the logic might be slightly different from what you had written, but essentially does the same thing more effectively. Meaning, you can think about it, right? If you have a complex logical expression, you can apply basic logical rules like De Morgan's laws and things like that, and reductions to just shrink it down to some normal form, which is as small as possible, but can't get any smaller. Yes or no? Theoretically, right? If you have a long expression, you can eventually say, well, if not this and not that, I can turn that into not, factor things out and refactor. Technically, given a lot of resources, you can, boil everything down to some minimal set of logical operations that gives you what you want. Yes or no?
Yes.
I guess I kind of understand what you're going for.
Yeah, what was I talking? What was that in reference to? Wait a sec.
I was asking about the constructor on line 15 and this data parentheses D next parentheses P.
Initialization. Yes, now I remember the entire thing. This does the initialization, and technically, I think it does not matter these days. It's just stylistic now. If you can do it, do it. Otherwise, just put it inside the braces like a regular assignment. Compilers will take care of doing all the right things. Yeah, now I remember this entire destruction. This train of thought, how it got started. about compilers and the code they generate don't even have to be what you write anymore, as long as it does what you intended it to do, which is really what a neural net is, isn't it? Okay, so are you good with this so far? All right, let me take a look. Set data. All right, so you set the data. Oh, great, great. Okay, very nice, very nice. Yeah, and it's all nicely laid out too, without the extra blank line. It looks nicer without the extra blank line, without the setters and the getters, which is very nice. And they're const. That's fantastic. All right, you also tag them with const, so that you can put an extra. Yeah, all right, cool. All right, const. All right, and then print node list. Well, this is almost exactly like the code we wrote last class. Okay, print node list. Okay, all right, and then get next is not equal to null pointer. I see. So you're calling the method get next.
Can you please touch on the arrow notation?
Yes. So if p was an object, you say p dot get next. Yes.
Mm-hmm.
But p is not an object. P is a pointer to an object.
Mm-hmm.
So you can't say p dot anymore. So you got to say p arrow. That's the only
Okay.
difference. If it's a pointer, you say arrow. If it's an object, you say dot.
It's just visually very messing with me. Like it's hard
No,
to
see,
read.
for
And,
first
yeah.
time it will mess with everyone. Yeah.
Mhm.
Especially because, minus and greater than have different meanings in other places. So we always get confused the first time. But it's like saying the first, the first time I think I was confused was double equals. Double equals was also confusing to me. The very, very first time I encountered. And things like that. Okay. So yeah, I understand, but you got to get over it. So dot and arrow. You'll get used to this very soon.
Mhm.
All right. So CO data. Oh, it's printing. All right. So and then a dash. One thing I realized was the first one was -1. And so we have -1 and then dash. So why don't we change the hyphen to something else? We say comma instead of a hyphen. Comma instead of
Right,
a
right here.
yeah. And then
Oh, I gotta
yes,
stop the program.
yeah. And then also before the null, say comma null.
Before here.
Yeah. I think this would look better because the -1 was getting confused with all the hyphens in between. All right, so add to end. I actually don't remember talking about this. This is Josh's code? Was Josh dictating this or add to end and add to beginning?
There
It
was
was Seth and Caitlin together.
and
So it's two people's
Wesley
code.
Oh, I
and
see.
you.
A combination basically.
Yeah.
It's a combination of 3 different
It's
people.
yeah, I see. I don't remember doing this. All right, okay. So it came around a combination of you guys somehow because I can recall calling this out.
It was basically regurgitating Josh's code.
Oh, okay.
I see from last class. Okay, so in fact I don't remember that either. But I remember he was talking through the code last class. So add all right, so given a node and you want to add it to the end of oh, I see. You want to add a data element to the end of the node. All right. So you go and you create a new node and then you set it to the end of the current node. I see.
Yeah, because you call set next.
Yeah. I wonder if we should call it it's okay as long as you guys know what it's doing. Because I had to end. In my mind, I thought I know what it's doing now. But in my mind, I thought add to end is going to add to the end of the list, meaning here's a pointer, keep on going all the way until you get to null. And then when it's null, put the new guys there and return. So add to the end of the list. So in my mind,
Yeah, it doesn't quite do that.
yeah. So that's why the choice of name matters. And that's it. So the choice of the name, now I know how it works, right? But the choice of the name made me think for 2 or 3 minutes longer than I needed. Yes?
For the add to end function, you have the node that you
Yeah,
pass in has to be the
It's
last
not
node.
it's not a big deal. It's not a big deal. And so that is why I think what happens is that eventually, as you code more and more with experience, what we find is that we spend a lot of time just coming up with names because we want to reduce the cognitive load on ourselves, coming back to it and saying, well, I don't want to spend the extra 5 minutes and to figure it out. Can I cram as much meaning into all of these things as possible? So that's what takes a lot of time, because most of the time, let's face it, after you've done this, CS2A and all of these classes, and some basic algorithms close and so, all these math classes and everything, you're actually done with a lot of these things, other than, going into specialized areas and doing hardcore research and in areas. So what I'm saying is that a lot of stuff that today, anyway, right? Maybe not in the near future, today that you do out there is just stuff that you already know, right? See, most people are just paid to do what they already know. It's not say, play around way in the dark and tell us where it's safe to go. Those are the other people, the researchers. But most people are saying, well, you do, or have you already graduated? Do you know how to do this? All right. If you know how to do this, okay, right, join us. And because you know already. So what happens is that most people just do what they know in one form, and then in another form, it's just sugar-coated in different ways. So you will recognize that very quickly. Once you start getting, I don't know how it's going to turn out in the next few years anyway, but, in the recent past, how it is, people just find out after jumping around a few times, they realize that they're not actually doing anything new in each place. They're just rehashing what they already have given in one place, just using different clothing in another place. And then it gets boring after a while. And you'll recognize this after a little while. And that's exactly what goes on with programming too. And you find out very soon that a lot of the sophisticated algorithms, there's always, there's lots and lots of really, really cool algorithms too, but they're all very specialized and so on and so forth. 99% of the algorithms are general purpose algorithms, meaning they're used all over the place. And there's a few, I think, I mean, maybe there are exceptions, obviously, right? But I think you'll encounter it. And I think our curriculum and everything, everything, or experience, or years and years of people trying to teach computer science, all of that, I think it's boiled up the most important things to the top, so that, the odds of students giving up increases the longer, because, you have fewer PhD students, fewer master students, right? And so on and so forth. So we want to cram as much useful knowledge into people before they drop off. So it's kind of a mathematical trade-off. There's a sweet spot. And, it's not consciously engineered, but it kind of fell out in the last several years, decades or centuries of learning, that, this is the way in which we have to structure the learning material, so that at the rate in which students drop off, saying, well, this is too much for me. I no more. I can't take any more computer science. I got to do something, easier. Right? So different people drop off at different points, and some people persevere all the way into a very niche and say, well, you know what, here I'm totally powered. I can go into this niche and mine for diamonds in this area that nobody else is looking at. And so few people survive all the way, because, survive meaning not through, meaning they're not distracted, or, gotten fished out, meaning they don't have other ways to branch out. Okay. So and because of that, I totally lost my train of thought. All right. So I think that's basically what happens. Let's get back to this code. All right. So add to end, naming of the code. And so that's what, 10 minutes. And I actually wasted a whole lot more than 2 minutes just because of this thing with the name. It's not a big deal, but you'll actually find, I think, that most of the time you'll find is, in this company, what is the name I should give this variable, so that it's novel and interesting and things like that. Right. So add to end. All right. Okay. So all right. So it just so that basically is add to the end of this node. We don't have to refactor it. If you want to refactor it now, that's fine. Go for it. And add to beginning is going to do this. It is going to create a new node, and then, oh, I see. Take P and P is next and add it. Oh, I see. It puts this guy in front or puts that guy in. I see. That's what it does. Okay. And then P set next time. All right. Okay, great. And both of those are separate methods that take the node as a parameter. All right. So here is what one of the things that you can do for later, for expert, is to, well, you're going to do in question number 9. Whatever you're doing here is part of stuff that you will actually import into your quest 9 homework knowledge, which is essentially creating nodes and attaching them at various points in the list. The 2 extra things that you will run into in quest 9, hopefully we'll cover this next week, is removing from a linked list, right? It's just slightly harder. And also traversing a linked list and pulling things out, cutting things, snipping things out. But we've got the basic working mechanics this class, which is, creating a linked list, playing around with it, printing it on screen. And today what we're going to do is also write a method which will do some basic animation of the linked list. Okay, so we give it a linked list and say show animated linked list, and it's basically going to show you the linked list with it scrolling to the left with the null pointer, like a train carriage, right? So it's just scrolling to the left until the null hits the left margin, and you stop there. Okay, so I think we'll create that animation. It's very easy to do that. And all we do there is, I'll give you a hint because I'm not going to talk you through this. We'll just do the comments and you guys have to finish it. Is you're going to do a for loop, and in a for loop you'll print the linked list using a loop that for whatever it is, that print statement, right? From P all the way to null pointer with the commas, and then print a /r, which takes you all the way to the beginning of the same line, not to the next line, /r. Okay, next advance one pointer to get rid of that guy, and now print from here again, exactly the same on the same line, right? So you're going to print all the numbers, and then a /r, come back to the first line, right? Up to null. Now, obviously, a couple of spaces after that to overwrite and clear the line, right? And so on and so forth. It'll look like that whole list is shortening. You print off with 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, null. Okay, and then say 9, 8, 6, 6, 7. So 10 shifted out, 9 shifted out, one by one. So the list gets shorter and shorter. So you'll create this animation. That's the animation we're going for. It's like 3 or 4 lines of code. 3 or 4 lines of code. Okay, and so I'm not gonna write this, but it should be fun for you guys to write and also test out in your main method, just like this. Well, in your main, what do we have in main right now? All right, yeah, clean it up a bit. All right, give me a blank line after line 54, so that it's we know that it's srand. Great. Okay, and then start node. Yeah, all right, and current node, start node. Okay, while true. All right, a blank line after int c input, int input after int input, right? And you're doing, and then c out. All right, and then function to do, and then you're switching on. All right, case. Now I think what, align the cases with the switch, but leave the statements in place. I think that would be easier to read. Further down on line 50, on line 65, just like yeah, back. Yeah, there you go. And the next case also, case I. Yeah, next one also. Default. Yeah. All right, okay. So all right, so you got AI, default is invalid. All right, let's add a type A to add a number to the end. All right, okay. And then cn break. All right, scn. All right, add to beginning break. All right. A print node list. Every time we print node list. All right, and return 0. Great. Okay. So I think yeah, run it one time, run it one more time. Let's make sure it works. Thank you so much for giving me the time to absorb this code. All right. Yeah, punch in a bunch of numbers, a bunch of odd numbers, and then we'll punch in a bunch of even numbers. Now we got commas instead of hyphen. That's cool. Yeah. Yeah. Oh, I see. You're giving it on different lines. You can give it on the same line too. A space 2, or you can have the same number more than once too. Yeah. A place. Yeah, 7. Yeah. Okay. All right. Now you can say I insert. Yeah. and yeah, 2468, and it's going this way. Excellent, excellent. All right, so it works. Now, all right, let's do the animation thing. Okay, and this is the part that you guys are going to write, and I'll just put the framework in place, and then you can kill this program. Kill this program. All right, let's go into the code, and then let's create one more option for case I. After case I, break. After the break, say case. What should we call it? For now, call it case X, right? What is a case X? Case X, and then and then put a comment there saying call no, you can actually call our method, but I was saying comment elsewhere, but we'll call the method here, right? So let's say animate, no, show animated list, show underscore animated list start node, show underscore animated list start node. Okay, so this is the bit that you got to implement, and it's going to be a void method. You can put the semicolon there and start the skeleton of it up there. Yeah, and put a semicolon there, and you start the semicolon. Yes, it's the skeleton of it. Yeah, above main there. All right. Okay. Now, yeah, stop there. All right, and put a space before the curly brace too, so that it's oh, you don't have it elsewhere. Okay, that's okay. Animated list. All right. Okay. So it's a comment on line 51. Comment on line 51. Go to line 51. Hit enter. Enter one more time. One more enter. Right. Now start the comment and say we want to display the contents of the list as a comma separated bunch of values ending in null. Uppercase NULL, right? Or comma null, whatever it is. Right? On the next line, no, I would autocorrect it. This, this is the thing with yeah, all right. On the next line, we want to say then we sleep for 0.5 seconds and print a slash. No, all right. No, wait a sec. 1 sec, okay. Oh, we want to display any null. All right. So, all right. So and then advance our list pointer to the next node and repeat on the next line. And repeat the same thing until the whole list scrolls to the left. I don't know if I'm doing a great job describing it, but I want to know if at least one of you have the idea in your mind, so that when I'm away and you're coding it, at least one of you know what we're shooting towards. Okay, what I have
the whole list. You said scrolls to the left.
Yeah. All right. So yeah, why don't I just describe what I'm saying in numbers using an example on the next line, and you guys can figure out what the language should be. Yeah. All right. Go to the next line. All right. So example is it might print on the next line it would print 10, 9, 8, 7. No, let's say 5, 4, 3, 2, 1 null. Okay, 5, 4, 3, 2, 1, null. Right? Then sleep for a second, and then print /r, then print /r, then print /r, no, \r, then flush. Okay, yeah. All right. Then sleep for half a second. Yeah, so on the next line, advance. Oh yeah, and then print 4, 3, 2, 1 null, comma 4, 3, 2, 1 null, comma. I don't know, a bunch of spaces, because it may not, because you're just going back to the same line. and then you're overriding it, but the previous line is left over. So you got to put some spaces over there to clear it. But I don't know a clean way yet of making sure you got all that. So maybe print a bunch of blank spaces for now. Well, leave it like that, and then we'll notice the issue, and then we can clean it up later. Right? So yeah, 4, 3, 2, 1, null. Right? That's it. No comma after null. No comma after null on the previous one too. Yeah, and then /r flush, sleep for 0.5 seconds. Yeah, flush, sleep for 0.5 seconds, and so on, right? On the next line, say, and so on until the pointer advances all the way to null. Right? Then you say return. It's just a void method. So it's just a void method. All the way to null, and then return. That's all. Okay. Is that clear enough? You know, there's a bunch of gobbledygook at the beginning when I try to explain all this stuff, but I think from the example it's much clearer as an example. So maybe you should just, you know, declutter that language, or basically get rid of the first 3 lines even. I say this is the example. This is what we're shooting for, right? If you want to show the animation of the list, you're going to show all of the list, you know, with commas, and then basically /r, go to the beginning of the line again. /r is carriage return, right? /n is go to the next line. So typically when we say /n, the operating system kind of gives you the illusion, saying, oh, you tell me /n, but internally I'll represent it both /r and /n. Because every time you hit just enter, is just sending /r and /n. So it's going to the beginning of the same line and to the next line. Because you went just to the next line, the /n, it doesn't go to the beginning of the line. So no carriage return. So it's just line feed. So so that's why carriage return is ASCII 13. And I think this one is ASCII something else, right? 10 maybe, right? 2 different values. You can look up in the ASCII table. And that is why we have this feature. Anyway, /r, go to the beginning of the same line. Now you can just write lots of spaces and erase the previous line completely. You can basically just have a string of lots and lots of spaces and say after /r, after the 0.5, before you print the next list, you just print that constant string of lots and lots of spaces. Bam, like that. It clears the entire line, right? Something like that. It's fun. Is that enough? Is that enough? Can you guys do that in like 10 minutes or 15 minutes? Is that okay? You know, it's 7:20, but you should be done in 7:30, 7:35, 40 or something like that. Yeah.
Yeah.
Great. Okay. So, and after that, what we can do is we don't have to do more coding, but what we can try and do is, just with the functions we have got, we'll just create a new class called list and move the stuff that we've already got. Like we've got functions out there, you know, they're global functions, say taking a node parameter and so on. We'll just create a neater class called list, but inside of list, we'll have the node. I thought we'll do one more thing before we get to that. One more thing, the one more thing I had in mind was getting rid of nodes, deleting nodes in the list. All right, while you're doing this, let me think of a way in which we can work that in. Right, we'll do that, and after that, we'll see, maybe next week, we'll do exactly this and say, well, we want to have a class called list, which will contain a class called node, which is exactly, you know, pretty similar to what we'll be doing in home, you know, your final homework, question number 9, which is, you know, one of the things that lots of people are stuck on. So we'll do that next class, next week. But you know, for today, I think this should be enough fun. And if we have time, we'll do after 7:45 when you guys are done with this. We'll do removing a node. Right, removing a node is going to be fun. Right? How you got a list? Now you say I want to get rid of a node in there, and once you master the trick. Removing and inserting nodes at arbitrary locations, not just at beginning, at arbitrary locations. Now you know how to do it at the head, you know how to do it or something like that. But yeah, you pretty much got all of it here. Yeah, add to the beginning, it should just be add to the next or something like that. But yeah, that logic is what you got to get your head around. It's exactly the same. in homework 9, most of the students get stuck here in push front and push back and so on. But this is basically what insert the node class. So, and they have an error saying, well, this is to do with node. Even before you get to your playlist, your node itself is being tested. That's what this means. Node insertion not working properly. And once you have that working, and most of the rest of it just falls into place. So it's good that we're getting to play with it and have practice early on. So I'm happy about this. So I'd like you guys to just play around with this. Let me know if you're stuck, if I can help you. I'm happy to jump in and code. But I'd like you to have the pleasure of doing that, right? So I think 0.5 seconds should be a decent animation, but play around with it. Maybe it's just 0.1 second. It'll look better. Yeah. And you can also think of, it's kind of jumping weirdly. What I want to do is I want to also make the comma move one out, then comma, and then a 0.5 seconds and things like that. You can fine tune the animation to look nicer. All of those things. Okay, right. Is that enough fun for about 10 or 15 minutes?
I think it will take way more than that, for me at least.
No. I'm pretty sure once you get the hang of it, and once you're all on a roll, it'll just start flowing. So
are we gonna be doing it in a while loop? Because like I'm trying to wrap my head around it.
I'm thinking of for loop.
For loop?
For loop, yeah. I can see a lot of ideas already, right? Try it one way. If it doesn't work, try it another way. Maybe it's taking longer than 10 or 15 minutes. That's fine. Who cares? Right? Because look, we're playing with these things a lot earlier than they are typically taken up in classes. So we have a lot of time. So nobody cares if it's going to take longer, but the important thing is just have lots of time to play with it. So are you guys good with this? Yeah. If you're like totally stuck, just call me. I'm back here to drive with you, but I'm pretty sure there are lots of people here. I'm pretty sure Josh has done coding with pointers before. Yeah, Josh, you're good with this too, yes?
I'm decent.
Yeah. All right. So if you guys all get stuck and there's nobody to help, just call me, okay? I'm just going to be here. I'm just going to be around. I'm just not in your face. I'll be on the other side, okay? I'll be on the other side, and I can hear you guys. So just keep me, audibly, I should be able to see that something is going on.
Okay, so how do we start with this? We pass in the start node. I'm a little bit confused on like we don't have a whole list yet. So it's not like we pass in the list of numbers that we, not list, but linked list of numbers that we got by using case A and case I.
Yeah.
So are we supposed to do it like on the fly?
Well,
Yeah,
there should be a print list function that's similar to what we need to do.
we have a print list function.
Yeah, but don't we need nodes in the list first and we add them in main?
Yeah, the function has a start node. You need to put node before that, the start node in 958.
Oh, yeah.
I think it's probably going to be a pointer. So put node star start node line 58.
I'm confused by the fact that we only pass in the start node.
Yeah, that's exactly my question, because the function is to show animated list, but we don't have a list yet.
Yeah, because the node, you start from the start node next, and you get the next node, and keep going until you get no pointer.
Yeah, but in the linked list, when we start, we have only one node. So
then you only need to print one thing, and it's done quickly.
yeah, my brain is not functioning apparently. No, I really do not get it. Like I understand the function, but I don't I don't still understand the input.
Because it wants us to print the whole list. So
Yeah, but
how do we?
how?
Yeah, I think we're
Yes,
asking the same question. Yeah.
yes,
It
yes.
will
It is
probably be
the
a
same
while
question.
loop since we don't know the size, how many elements are after the start node. We can't like put for whatever, so it has to be a
Oh
while.
yeah, wow.
And it's like while
Yeah.
it's not no pointer.
Yeah,
Wow.
that's valid. But then again, when we're gonna test it, do we super confused? So the question is when we're not passing, we just passing the start node, and we assume that there's something else in a linked list. So we
Well,
will write this function assuming that we're working with a list, right? But then
it
we're
should be
testing
able
it.
to work with one or more elements.
Yes. I understand that part. The part that I'm concerned about is when we're going to test it in main by using case X, right? We not adding anything to the list. So initially we just have one start node and then animation on just one node doesn't
We can make like a test list.
Yeah, okay. Okay. So in a while we're gonna print, I assume,
Yeah.
first. Print
Yeah.
node.
What's our? Should we
Start
do
node
something?
not equal no pointer.
Yeah, something like this. Wow.
Yeah. Oh, you don't need I don't think you need a star now because you already does he need a star, Josh?
No,
No, okay.
because
So
if you put a star there, it turns into the object.
mhm.
Actually, since we're gonna be like iterating, we don't want to change the thing that they give us, which is start node. So before the while loop, make a new node, current node equals start node.
Mm.
Right. So we're gonna be changing current node.
Node, current node.
Yeah. Equals
Wait.
start node.
Node with no asterisk.
You need star.
Yeah, you need star.
I don't
No,
understand. I don't know if I.
No, the node. And I'll remove the other star.
This one.
Yeah.
Wait, what? Why?
Because it's already a pointer. If you put another star there again, then it turns into an object.
I didn't know it can cancel itself out. That's kind of cool. Okay, so we're working with current
I'm
node.
lost here. Okay.
So you already don't be lost, we can find you. So when you declare show animated list and you said node star start node, you already declared that thing as a pointer. And if you're going to put a star again, then it will turn into an object which you don't want. So basically you use star one time already on that variable. So I'm sorry, on that pointer, so you don't need to do it again. And when you create a new one, well, like right now in the while loop, you just say current node, not a start current node, because you already used it. Like that's how I think about it. A little bit,
okay.
A
little bit primitive, but works for me.
Right, and a pointer is not an actual node; it's just a memory address, so they are not interchangeable, even though they have like similar names.
Okay, so what we're gonna do, we're gonna print a list. So I guess let's call the function print node list on the current node. Yeah. Then I think we should the current node we need to get next, right?
Current node equals current node arrow next, or get next.
I think we have get next.
And then sleep for half a second.
Do we need to like
yeah, we need to include do we need to include what is it for sleep?
Is it clock or
chrono? Which one is it?
Are we doing chrono or uni? The other one.
Well,
I don't care. Is it this? Chrono?
what did we use the last time? Okay, I think we used uni std.h for sleep because we're using sleep, right?
UNI dot what?
No, UNI std.h.
STD dot
H.
okay.
Yes, that one was for sleep.
Okay.
Okay, I lost
Enjoy just
where I was.
we
Okay,
just
so
type-
sleep 0.5. 0.
then we want a \r, then print \r.
Does it what does it do? \r.
That is a good question.
Let's try it. I mean, why not? And then flush.
What's flush again?
I think flush is taking everything out of the cout, all the previous things. But someone please correct me if I'm wrong.
Like how do I call flush?
I think you do. Yeah.
We just slowly do that.
Yeah, I think so. I'm pretty sure. No.
Okay.
R flash 3, 4, 5 seconds.
Wait. No.
Should we
print? Oh, sleep comes after this.
I looked it up and \r is a carriage return. So it goes to the left, or the cursor moves back to the most column.
Mazen also added to the chat. It tells you someone related to move the person on the start line. Okay,
Until
that's
you
kind of cool.
Okay.
That's kind of cool. Then sleep. Is it?
We have to remove. Now I have to remove the first element from the list.
Do we need to? We cannot remove node right now. We didn't write the method for it because we just got. Should we try and test what we have right now or not?
I'm looking up how you remove an element remove a node from a linked list. I don't know.
Because I think Professor said that we're gonna do it either next time or it's the next thing to do, but not for this one.
Well, how do we do this without?
That's a good question. Let's ask for help.
Professor.
Professor.
Yes.
I found an example code for deleting a node.
Oh, for delete. Oh, just give me a second, okay? Okay.
After the while loop, there should be like where it just prints null.
Just see out null.
And then return, cout null and then /r.
Okay.
Because
Wait, why
it says and so on until the printf advances all the way to null and then return. Because the while loop only runs when there's actually something to print out before the null.
I'm sorry for this very stupid question. Are we putting a string null or?
Sorry.
Yeah, the string null.
Okay.
Yeah, go ahead. Complete your conversation. I don't mean to interrupt. I'll just get ready.
No, we pretty much.
I think we need some help.
Yeah, we do need help. That's for sure.
What's going on?
So this is what we have so far. I don't know if we're
All right. Yeah, it looks kind of okay. Yeah, let's clean up. Give me a blank line after line 60. So let's go on to the next line. All right, so while count node is not equal to null pointer print a node list. Yeah, great, okay. And then current node equals yeah, okay, /r flush. Sleep. No, actually, sleep doesn't work with negative. By fractional numbers. Hey, you need use.
Oh,
Yeah. Someone used sleep. Someone used sleep for one of your animations.
I think I used it in the mouse thing.
Yeah. Use sleep 0.5. I think whatever Arena used. Is it maybe?
Oh, I used something weird.
No, I think it was sleep. Sleep. Someone can Google and find out how to use sleep. Maybe there's a library. Maybe there's an include file that you got to use, but I think it's okay. Sleep.
But I think you sleep is
it's
in milliseconds, right?
Oh,
It's
it's in
millisecond. So we
it
need
is
Yeah, yeah,
the
thank you.
5,000.
it's the same library, but yeah, it's microseconds.
Yeah.
So what
like
is that? 500 microseconds?
500, 5,000?
1,000. I
No,
think.
5,000 is 5 seconds, isn't it?
Oh. Okay, then
500.
500? 500 in milliseconds, right?
Yeah, 500 milliseconds. That'll be half a second. And we
Okay.
can come back and revisit it. You can even change it to a 100 later on to get decent animation. Yeah.
It's
No, not 5,000.
500.
Make it 500, 500, 500.
It's 500,000 microseconds for a half second. I just Googled it.
Oh, I see. It is microseconds, not milliseconds.
Oh,
Yes,
damn.
yes. So it's 500,000.
500,000.
Yeah. I should have known this. Yeah, because I'm pretty sure now. I remember now. I think I hacked Rena's code when she posted it, and I think she had 100,000 with 6 zeros, and I changed it to 10,000. That's why I got the mouse effect with scurrying around like a mouse. And then I think at that point I realized it must have been microseconds. So I was kind of expecting milliseconds. I don't know why. Because because sometimes if you've been programming Java or JavaScript, for example, I think you are more likely to have used to sleep in milliseconds. Even in Python, I don't know. Yeah. And Millie is pretty, decent for most of our operations. So that's why we got thrown off track. Thank you so much. That should work. Why shouldn't it work?
Also, Josh suggested that after the while loop, we should print null.
Yes, yeah, totally. We should print we should print null at the end before the use sleep. Yeah.
Why
Actually
are we
move the use sleep out of the. Oh, I see. You got the while loop there.
why are we printing null if isn't null already in our list?
No,
Because
no.
the while condition of the while loop is current node has to be not equal to null pointer. So like the last line has to just be null.
Hey,
So
I
that will
think
never run.
I'm sorry, yeah, and print node list. You got the entire line there. Yeah. You got the entire line ending in null. Hey,
Yeah.
Josh, was that the answer that you were giving, or someone asked for? That thing that says print node list, you have another function elsewhere, if I'm not mistaken, that prints the entire node list with the word null at the end. Yes or no?
Yeah, because up here in node list,
Yeah.
node list
That is
already prints
correct.
null.
Yeah, it's
Okay.
gonna print the null. So it's gonna print the null. And then after it prints the null, you're gonna advance it by 1, and you're gonna sleep. And then after you sleep, what would be nice is if you clear the entire existing line, but we'll figure that out later, okay? Because you'll see what the hell is going on. You'll see the L, dragging on with lots and lots of L's maybe, or something like that. But we can figure out what to do. It'll look
Do we
nice.
have to add a method to remove a node from the list, or does this?
No, you're in fact, node start node, you make it const node star constant. Oh, you can change. Yeah, make it const node start node.
Here or here?
Yeah, the declaration. Yeah, the declaration itself.
Node
No, the
const?
word goes before the node. Yeah.
Oh, here.
You can't change that at all. You can iterate through it, but you can't change it. Yeah. So that's a constant now. And then you got a current node, and you're going through the current node, and then the current node is getting reset to the next, and so on. oh no, you print the whole thing and then yeah. All right, you print the whole thing and then you reassign and then you sleep for half a second. That I think should work. Now at the very end, do you have flush at all? By the way, you do have a flush. Put a C out endl at the very end, just so we don't mess up, at the very end, after the, I don't know, at the very end. Yeah. No, even outside the loop, outside the loop, outside the loop.
Oh,
Yeah, C out endl. Just so we don't have, stuff overriding what, if you run it, I think you'll see the animation. I'm pretty sure.
do I have to call this function?
Oh, you
Oh,
haven't
we didn't do this part yet.
Yeah, all right, okay. Yeah,
Oh wait,
okay,
I
yeah,
can
okay.
just
Yeah,
do
you can
that,
just,
right?
Yeah.
and you can break. You have to break after that.
Oh, right.
Yeah, I'm pretty sure if you run it now, you add a bunch of numbers and then we can do the animation also. What's going on?
Do we declare void for show animated list in
Show
main?
animated list. Where is it?
Uh,
Where is it, by the way?
Oh,
think
I guess
so?
we don't need this.
Yeah.
Oh, no void, no void. Yeah.
We got an error on line 60.
Oh, it's
Here.
const. I see. Get rid of the const for now. I was actually worried about that at that point. I got to look it up. Yeah, it'll work. Oh, what's going to the next line? No, it shouldn't go to the next line. It should just go, the same line should just be getting better, smaller and smaller. Go to our function, show animated list.
Yeah.
No, we're not doing a /n, C out /r and then a flush and then sleep and then you go. Oh, print list. Oh, darn it. Yeah, print node list has got a /n at the end. The print node list has got, go to your print node list guy. Yeah, get rid of
Oh, 'cause we
that
have
endl. Get
the
rid of
endl.
that endl. Yeah. Yeah, well, anyway, it works. It works, and you can actually have, yeah, and in fact, you can, and so here are the things that to watch out for. One of the things, obviously, is that dragging L that I talked about, because it's pushing, going to the beginning, but the L is not overridden. So you can come up with ways in which you can do it. You can always say that, after I go back to the beginning, I'm just going to print a whole line of blanks to wipe out the previous line and then print my new line. Okay, that'll work. That's a simple enough solution to do. You can do it right now too if you want. And then you can also change the duration from 500,000 to 300,000, so it'll animate faster or slower. Yeah. And what was the other?
Why is that dragging L happening?
I'll show you. Right now, after you do the use sleep, but just before you go to the print, before you go to the print node list, yeah, before on the immediately, yeah, there you go. You can say a clear current line, okay, clear current line, underscore current line, and we'll just define another function. And no, open close, yeah.
Oh, right, good.
And now you can define a function up there, and you can say void clear line, yeah, and you can say C out a whole bunch of blanks. Yeah, within lots and lots of it. There must be a way. You can figure it out. No, you need even more. I think you need a lot more, because in fact, go to 100 lines even. 100, because you're going to be creating a list iteratively even at some point. Yeah, and so yeah, that's enough, I think. Yeah, that may scroll and all. That might have weird effects, but And then instead of having to go through this laborious process of saying A1, I1, and so on and so forth, you just do a loop, a for loop, in which you just insert random numbers, insert random integers. Did it work, by the way, in this case?
Put a /r in the clear current line.
Say X again, one more time, maybe.
Wait, X again?
Yeah. Why is that going to the next line? Why is it going to the next line?
I don't know.
All right, so it is a very simple enough bug, okay? I can debug it if you want, okay? No, okay, no, yeah. Oh, I see. It's going to the next line because it's silly, big ass cout. Yeah, it's actually not going to the next line. It's wrapping around to the next line, so it's giving that ugly effect. Yeah, I think that's enough. That's enough. Yeah, I think it'll work now. And in fact, you can also play around with iteratively in a for loop, creating all the lists, elements in the list instead of having to create it manually like this.
Oh,
What's going
So
on? Oh,
Put a
you gotta do a
/r in
slash
the.
R. You gotta do a slash R after all the blank lines because then it's print the blank lines and go. Yeah, you want to print a slash R after at the very end of that, and then a flush also. But put a slash R at the very end. No, you can just put the slash R inside of the string itself. No, backslash R, backslash.
oh, right.
Yeah, and then you also need to see out a flush. Yeah, flush. Yeah, okay. Now I think that should be okay. And now here are the times you'd be wishing that you have an iterative for loop
Yeah.
the links for you. There you go. Okay, well, it's kind of animated and it looks okay. You can play around with this, okay? You can play around with this, the animation. And also the other thing you can do is, you know how it kind of moves in a kind of jerky way? And I think it is because too much movement is happening on each sleep. You can actually, I thought about this. You can say, I'm also going to make the comma part of the movement. So what happens is that you have this big thing, the comma will move, and then a 0.1 millisecond, and then the rest of it moves, another 0.1 millisecond. Whatever the delay is also for the comma, or half of the delay is before the comma, half of the delay is after the comma. I think that would actually work much more nicely in terms of the animation when it looks. What have you got?
If we want to fix this with spaces, we could also just add an extra empty line after null.
Yeah. Yeah, totally do
An
that.
empty space, because that would, cover over the remaining L.
Are you guys okay with playing with it? Do you want to play with it? Hey, by the way, is Isidore here? Isidore, are you here? What time is it now? He said he'll join us at 7:45 or something. Well, he should be here soon. When he's here, we'll basically start talking about this project and research report for RSLS, and the ones who are interested and can stick around to participate. But other than that, I think that we've got the gist of it. Do you guys want to play around for a few minutes until Isidore arrives? Okay. After Isidore is here, we'll start talking about this RSLS project that you're going to be implementing. I think it'll be great fun. In fact, we'll just use the next 5 minutes to chart out the first few steps and the high level directions and what everybody should be doing. And we don't have to meet tomorrow unless you absolutely need to. Yeah. Okay. All right. Hey, yeah, people should feel free to take off. What time is it now? Oh, it is 7:50. Right. You should actually feel free to take off. Where is Isidore? Well, if he's not here, unfortunately, we have to meet tomorrow. We'll see. We'll see. Okay.
what time tomorrow? I have therapy at 12.
Yeah, I know. Let me get in touch with Isidore and ask him. Just stick around for a few minutes, okay?
Mhm.
I'll ask him. Oh, he just sent me email. All right, thanks for the heads up. No worries. Thanks for the heads up. Oh, where can I access a Zoom link? Well, he can't. He doesn't have the Zoom link. Let me see. Same link as the one you used before. Do you not have it? So I thought it was he has been in the meeting before, yes? But I'm pretty sure he was in the meeting. I introduced him.
Yeah.
So it's the same one.
Once.
Once, yes.
Once, yeah. Anyway, so and you know, on that topic, if you have finished all of the 9 quests and you're in good standing in class and you know doing all of the homework and expect to have an A minus is okay too, but A ideally. And would like to be an embedded tutor in the CS2A section in spring, okay? We have the opportunity. You can do exactly what Isidore is doing. However, I have this constraint and request. You already have your social security card ready before you agree to volunteer, okay? Because that's the greatest trouble we had with Isidore this time. By the time he could get his paperwork done, you know, it's like we're now like in next week is going to be like the penultimate week, and that's when he's getting ready to tutor. Okay, so it will be a great experience, and I think you're allowed to charge maybe even 20 hours, 18 hours a week. You can charge, and you can just attend these classes, and they'll each hour of the class will actually count, and then you can hold tutorials like you do, participate on the Reddit. You'll have a great time. You can talk to Isidore, okay? He can tell you informally anyway how much fun it'll be. Okay. Plus, you'll also get to take part in all the interesting projects we're doing, all of these things. I'm pretty sure there'll be more opportunities in spring also. Okay. Just like RSLS, there might be other opportunities. Maybe, you know, there might be a STEM showcase with interesting projects done in STEM. I recommend you guys do that. So many opportunities to come. So please stay in touch and be in the class, and also I don't know. Anyway, all right, okay. Are you ready to share the code? By the way, who was coding? Who was the last one who was coding? Was it Wesley?
It was Seth, and he shared the
Seth.
code in the chat.
Yes, all right. Not just a chat. I think, Seth, what you should do is make a post on the Reddit, share the link, and also share a paragraph or a couple. Hey, Isidore, you're here finally. Okay, thank you. I was just about to, you know, give up and say, all right, let's go. All right, so let's, Isidore, switch on your camera. I'll just wrap up this, and then we'll talk about this RSLS project. Yeah, Seth, when you post this, say that this is what we're trying to do, and the goal is to have a list and show the animation in it. Next week, we'll try and do the same thing and attach these to a list class in addition to the node class. Okay, we'll try and do something like that. Or maybe we'll do a game that's based on this or something like that. Okay, so that's what we'll do next class. All right, thank you very much.
I can share on the Reddit.
All right, yeah, share it on the Reddit, and also just, you know, not just the link by itself, but also you know, a paragraph saying what we're trying to do. Because otherwise, I think lots of people don't click on it, and many of the students will say, all right, I'll just read the book and see what's there in the book. That's enough.
We want to create a list class.
No, don't say it, but yeah, you just say what we're doing in here. That's enough. You don't have to say what we'll do next class and all.
Oh, okay.
Yeah, you say what we're doing here is fine. You just want to create an animation and play around with your own imagination and do your own animations. I think that should be enough for other students. I'll also get the recording and post it to this time, okay? So don't worry. Of the video. Isidore, all right, great. Thank you for joining. Fantastic. Thank you all. All right. So the ones who want to participate in this project and that for our SLS, stick around and then we can talk about that. Ideally, all of you don't have any work to do with the questing because you're done with quest number 8, which is actually an easy one. So you can participate in that. Isidore, he's he's our tutor. He's our class tutor, by the way. Isidore, I was just talking about you when you showed up, okay? I said that anyone, you know, you guys are welcome to volunteer for being the STEM tutor, you know, for the, what is your position called? Embedded tutor, embedded tutor for next quarter. And talk to Isidore if you want. But I have a precondition that you have all your social security and all the other paperwork done far in advance before you apply for this position. Because I think that was the biggest challenge with Isidore. So you can obviously talk to Isidore about that. He's our tutor. And I think he should be ready to tutor anytime, right? Around now. He's also he's also doing the 2B, and he is interested in being the, you know, principal investigator of this project. Okay, principal investigator. Basically, this is what it means. Everybody does the same work, but one person actually coordinates everything. And essentially meaning that it is easier for the faculty member to coordinate with the principal investigator, and everybody else, you know, plays pretty much the same part. Now, one of the things that Isidore will bring to the picture is this is my expectation. Isidore, you should correct me if I'm, you know, I can do this. You can use. I don't know if you have any of you have GitHub with Copilot and things like that. You can have AI to generate the code for you. But basically, what you want is a very simple web app which will implement the logic of the Grady game, okay? And it should be flashy and nice, and yeah, you should probably have, you know, nice sound effects that you can get from open source techniques. You can actually ask ChatGPT to do all that. It'll do all that and wire it up for you. I don't use any, it's just be native JavaScript, okay? Not any frameworks. And I'm pretty sure it'll be less than a couple of pages of JavaScript and a nice little app. So it's going to play the Grady game in JavaScript, and the way that, and you can take notes if you want. And I'm thinking, and we can refine this after we have the first iteration. We'll play it and we'll say, all right, well, let's change it and have it this way. And I'm thinking the whole thing, game ready to play, happens by tomorrow or day after. Meaning by tomorrow we should have it. Okay, we do a couple of dry runs, make some tweaks, but day after we're ready, which means on Saturday we're ready to go with the game. What that means is that by Saturday, you also finish up the proposal for RSLS, which is on that link, and you're all going to be co-authors. Isidore is the first author, and I'm not any of the authors, okay, or any of the co-authors. All of you are, but I will help you with the template of the paper. I'll even put the first version of the paper together and what the table should be, where the tables should be, and what the graphs should be, and what the conclusions and all, the first draft of them anyway, right? And then you can flesh them all in, just like we're doing with code. I will help you every step of the way. But I'll let you know when everything is got to do. By Sunday, we do the proposal with all of you in there, and you are at that point until May. Imagine how much time you have. March, this is middle of March, until the middle of maybe target the middle of April, 1 month. We have 1 month, and after that, we're going to work on the report. So 1 month of data collection using the app that Isidore is going to build, and I will host on nonlinear media after doing some checks. Is that okay, Isidore? Yeah.
Can I just so we will do the kind of we will do everything in JavaScript, like the front end and
everything,
the kind of
everything.
Okay.
The only thing it has to do, it has to send an Ajax PHP call to a JSON, and I will save the JSON somewhere. Yeah.
Okay.
Yeah. Okay. That's all. So we'll figure that out. Once you have the rest of the logic there, we'll figure out here's the data packet that we want to send back to the server. And because once it's in the server, I can put in a file in a CSV or parse it in somewhere, put it somewhere, and then you can just write a program that will look in the file and look at different cuts of it in real time, and say, hey, you know what? So many people have, and it's a very interesting game. I think one of these guys implemented it before, maybe Caitlin or Rena or Rui. I think I remember. Okay, I think.
Not me.
Wesley.
I think it was Ray. Was it?
Roy, you were the one.
Yeah.
Great gaming.
Yeah, it's me.
We did so many projects, okay? We did so many projects. Everyone has done different versions of different things. I keep forgetting now, which is actually a good thing, isn't it? It's a good thing that everybody's got a chance to do so many things. That's absolutely fantastic. Yeah. So, Roy, if you can share that code that you have done with Isidore and say, this is what we've done. We'll and also play it a couple of times. And Caitlin, you can also chime in. Maybe you can have a meeting tomorrow. You can coordinate sometime, or even just over email, right? If Isidore or one of you can just open up doesn't have to be Discord. Well, it can be Discord if you want, right? On Discord, you can open a Discord. Are you guys okay with Discord for this? All right. So
I'm
one of
fine.
you open up a Discord channel. Maybe add me as a, invite me if you want. Open up a Discord channel just for this RSLS Grady, the Grady game RSLS. Okay. And we're in there. And in there, the first thing to do is Isidore has got to do this web app. And the second, and then we'll set up links on Discord too, where you can actually go and click at any time to get a view into their data as it is currently being done, right? So you can actually share the link with all of your friends and relatives all over the world, and we'll get real-time data. And look at how exciting it will be to present this data in the RSLS, right? Presenting it, it'll actually be a great deal of fun. Lots of parents of your classmates, other people in university, and they'll all be there. And they'll all be interested to see too, right? It's a very interesting thing, and it's also topical in many ways, I think, right? Because it is a completely different kind. It's a different paradigm of computing that we're only just getting used to, rather than understand. We don't even understand how it works because it is emergent behavior. Because I think of emergent behavior in neural networks or computer science as akin to or very similar to um, quantum entanglement in physics, right? Neither of these we can explain. It happens, and then we learn how to live with it or to use it to our advantage. That's all we can do with quantum phenomena. It's just action at a distance. We don't know how it happens, right? Emergent behavior in neural net, we know what happens. It's there, but we can't explain it. The best we can do is just dissect it like a brain and say, well, this tissue does that, but we can't. It's just emergent behavior. So it's a very interesting time to be saying, well, this is one of the reasons why emergent behavior is actually much more powerful than analytical behavior in many ways, because it's feed forward. So you have a signal and it just propagates right through without any loops, right? Bam, like that. And you have the answer. And the answer isn't just flowing through, right? So you have that experience. And you'll see that it's much faster in many ways than iterative solutions, I think, right? That is a hunch. And you can try to confirm that. It is the first time I'm actually doing an experiment on a total hunch, not really based on any solid research or anything, but I think it is a very scientific experiment because it doesn't matter if someone has done a similar research project somewhere else. It'll actually be a very interesting way in which you can exercise your muscles and scientific experimentation, saying here's what I'm going to do. Because if you go to a kindergarten, kids are doing their experiments in biology and science and things like that. And how many days does it take for a bean seed to germinate at 90 degrees or whatever it is, right? It doesn't mean nobody else has done it before. You want to do it because you want to get the experience. And I think this would be a very nice and interesting way in which you can get experience in not just doing the experiment, cutting data, and analyzing the data, or presenting a paper and doing it in a research setting, being able to defend it like a PhD thesis, saying, well, here it is, here's my finding. If you find something wacky in it, let me know. We can look in the data and give you more data information saying that's why it is. Right? I think it's very exciting. So I will look forward to it. So we don't have to have a meeting tomorrow. Is that okay? So someone, I hope, who's going to set up the Discord, by the way? Is it or isn't basically the person PI of this? So if no one sets up Discord, I'll ask Isidore what the hell is going on. Okay. Isidore, are you okay with this?
Yeah, it sounds good. Yeah, we'll feel like someone needs to set up the Discord server, and then I'll try to work on the web app until Saturday, and then maybe we can have like a meeting where we go through everything so that like everybody is on the same page.
Fantastic.
And
then
then we can do
share
like
the screen and we'll play the game too. You can
Yeah.
share the screen and then we'll play. You host it somewhere. You have somewhere to host it initially, right? Before we put it on.
Yeah, I'll host it. I'll work that out.
Great. Excellent. Thank you all so much. We have a lot of people interested in this. Everybody should participate. Yeah. And the more the people participating in it, I think the more RSLS will also encourage you guys to do it. So I think it is fantastic.
Yeah, I can set up the Discord. I'm creating one right now. Could
Great.
everyone give me their usernames?
You just use our, you just come up with some scheme, okay? Just come up with some scheme. You guys did coordinate this. It doesn't matter. Just let me know what mine is and when I should join, and I'll be happy to do that. Yeah.
Okay, so if everyone can drop their username on Discord in the chat right now, so Caitlin can add them to the server.
I just realized
that
you
would be
can
great.
do the link.
Yeah, just
so
use Anand
I
for me,
just
okay?
I just dropped the link in there.
Okay, awesome.
Yeah, I see. When I sign in, yeah, I'll just sign in with my existing Discord thing. I've used it in the past, so I'll just sign in with that. So that's basically it. I don't have anything else to say. Is that okay? Everything else, most of the rest of it can happen on Discord. We even have a meeting later on Discord and coordinate these things. But I'm, hopeful we'll get things done by the deadline. Great, fantastic. Is that okay? Can we sign off? Yeah.
Yeah.
Was today's class good? Yeah. Was it useful today? Or did you guys
Yeah.
have a? Yeah, it's not getting fireworks now. Yeah, it's supposed to rain if I do this. Does it rain? Does it rain?
No. Oh, yeah, it does.
Yeah.
It does.
Okay. Well, it does rain. It does rain. All right. So fireworks better than rain. It actually gets brighter and then darker. Very nice Apple Silicon stuff. All right. Excellent. Thank you very much. I'll see you guys
Thank you.
next week. Hey, have a great weekend. Oh,
Good
I'll
night.
talk to you on Discord before then. Bye. Good night.
Thank you,
Thank you.
President. Good night.
Bye.
Good night.
Bye.